I define real marginal cost as the marginal product of labor, or the real wage divided by the marginal product of labor. This might not be the definition that you learned in micro class. So let's look from our production function, we can get to this result in the way that you may have learned to do this in the micro class. So again, the question, lots of different things, the same things taught by different professors or in different problems. Right? A lot of these things are connected. Right? I don't think of econometrics and micro and macro as three different things. There's lots of overlap. That's the whole point. The pieces sort of fall in place together. Yeah? So let's kind of look at this from a microeconomics perspective. So let's take our total nominal costs, right, as the wage times the amount of labor that we demand as a firm. Our production, let's call this the quantity, is then with our production function, it's AT, the productivity per worker, or the total factor productivity, then times the elasticity, or per workers times to the power of their elasticity. Right? And we can solve this out to get our demand function for labor, for a given amount of quantity. I want to call this our demand function based on that's just defining the labor needed for a given level of production. We can now substitute this into the expression up above, and we get a cost function, a function that tells us our cost as a function of the quantity that we produce. And our nominal marginal costs then are going to be, what's the derivative of our costs with respect to quantity. All right, so now, W's out in front, we have this a to the power of, or 1 over a to the power of 1 minus alpha stays constant, so we just take the derivative with respect to q, pull down 1 over 1 minus alpha, and subtract 1 from the exponent. All right, and for the real marginal costs, we just divide that through by p. So now, if we know some of the quantity we're selling, this is the amount that's going to be consumed, which is the entirety of demand. So let's replace this Q, right, with YTI. That's the demand for our good with firm I. And we get our marginal cost as a nominal marginal cost is the expression we have here. And when you rearrange this, right, you see, wait a second, I see the real wage already inside there. And this expression here, right, it turns out is hopefully, right, the marginal product of labor in the inverse. The marginal product of labor is 1 minus alpha times AT and IT to the power of minus alpha. All right, so if we use the definition from the lecture, we get this expression here. So the question is, are these two equivalent? If for our labor function here, if we plug in this inverse of the production function, like we just had before, so this, as I said, this labor demand, but not really demand, it's just determining labor for a given amount of production. We're going to rewrite the problem. For n, yeah. So from the class, we plug this in here, and right for n, put it in here. We start to simplify, and we get then the same expression that we get perhaps from the way of doing things from micro. Yeah? Right, and this is going to hold. So for any function, really, as long as we have the ability to differentiate it, to invert these functions. So if we have smooth functions, then the explanation that I gave you so I said that the derivative of some costs with respect to output, so this is marginal cost, is equal to the change in cost with the change in our labor input times 1 over marginal product of labor, simply because we write this out by dc over dn, and this gives us then dn over dy. And mathematicians hate this. They say this is wrong, but physicists do this, and I don't know. I don't aspire to be as mathematically correct as a mathematician, as an economist, so if the physicists do it, right, we should be fine. You see that this is the exact same expression. Right? But for us to be able to do this and for these things to cancel out and work right, we have to have functions that are, where these inverses exist and they're sufficiently smooth. Right? Okay. Right, so in general, this is not going to be an issue, certainly not with the functions that we usually use as economists. They're almost always very well behaved and smooth with well-defined inverses. All right. The next question, let's interpret the New Keynesian-Phillips curve, and then we'll interpret the New Keynesian IS curve. All right, so our New Keynesian-Phillips curve, inflation today depends on marginal cost today and future expected inflation. All right, so it's always good to remind ourselves, where does this come from? What's underlining this? This is the optimization and price setting decisions of firms who are maximizing their profits under the assumption of sticky prices. So all firms would like to change their prices every period, but they cannot. All right, so a firm that is given the opportunity to change its price must take into account that it might not be able to change its price for a while. Right, so this gives us that price changes depend not only on current conditions that would affect desired price changes, i.e. current marginal costs, but also on future expected marginal costs, future expected drivers of changes in desired prices. And so if we have this as marginal cost deviations from their steady state, then inflation is going to be constant, prices won't change, right, if marginal costs aren't higher than what they are in our steady state where prices are constant. Right? So prices will start to rise, inflation will be positive when marginal costs rise above this steady state value. What our firms are trying to do, right, by adjusting their price, they're trying to bring the markup over their marginal costs in line with the desired markup, the markup that would be optimal for them. Right, so what we have is that if the markup is too low, firms want to raise their prices, right, to bring that markup over the marginal cost to where it should be. The New Keynesian-Phillips curve is our supply side in the New Keynesian model. Okay, how do real marginal costs relate to the output gap? Right, we have, intuitively here, the more we want to produce, as we want to produce one more unit of output, we're going to have to hire increasingly larger amounts of additional labor, right, because we have this concave production. All right, so this means as we want to produce more, we're going to be facing higher marginal cost, real marginal cost. Each additional unit of production is going to require us to hire more additional workers than the unit of production that came before. So, rising marginal costs with production. We can relate these costs to the cost of a worker as the real wage, right? But what we then have is that as if output is above its natural level, so if we have some increase in output above what would be, if we have some increase in output on the aggregate, this means that firms are producing more than they were before, which means they're hiring a disproportionately larger amount of labor than before, i.e. their marginal costs are also increasing. And this gives us the direct linear relationship of marginal costs and output, or marginal costs and the output gap. Our new Keynesian IS curve. This is great. We've thought about the IS curve since Macro 101 in our bachelor's program. This has some subtleties to it. We have the negative relationship between a measure of production and the nominal interest rate, or the real interest rate, depending on how you looked at the IS curve. It has we have an equilibrium on the goods market here, right? But it comes from our IS curve. It comes from, our Euler equation. Right? So this is from our household's optimal consumption savings problem. Right? This is emphasizing that what might not have been clear when we first thought about the IS equation, or goods demand, is that a household's decision on how much to consume is the same thing, it's the flip side of the coin of the household's decision on how much to save. Right, so really is an engagement with financial markets, which is why we have the real interest rate here. Right, and so notice also we get this negative relation between output of your production and the nominal interest rate without talking about investment. We don't have, right, we just have consumption in this model. There's no net exports, there's no government, there's no investment. Right? So here we have the dependency of the consumption function directly on the real interest rate, and it's negative. Right? We would expect this from our simple consumption savings model from before. Right? But what makes this then not so simple, right? The logic here, when we solve this forward, we see that the output gap today, if we're going to think of our consumption decision today, depends on not just the return on savings in real terms today, but tomorrow or the day after and the day after that. It depends on the entire sequence of future expected real interest rates. And so this is interesting. Like if we take some baseline rate, so let's call it the natural rate, and any increase of the actual expected real interest rate, so at any point in time, would lead us to increase consumption, or to decrease consumption, today. Yeah? Right? So if you get news, 30-year interest rates have gone up. This is going to lead to a reduction in consumption today. And we're not going to wait until 30 years from now. Right? None of this is going to affect our consumption decisions now. And we would sort of expect this because we've seen the connection of short terms, like the short-term interest rate of 30 years from now, with the long-term interest rate, the 30-year rate, and how that relates to our consumption decision today. All right, so this gives us the demand side of our new Keynesian. All right, this solving forward is just written here. Right, this is also something that's, so you're thinking strategically about the exam. So I'm only going to look and talk to you when I talk about the exam, because you asked the question. So the strategic question Here we're solving the new Keynesian IS curve forward. We've solved a number of equations forward, right? That might be something, right, that seems to be important here. Right? So in terms of something to practice that might show up in the exam, look at these two equations and solving them forward seems to be useful, right? There's nothing complicated mathematical about it. If you look at a smaller equation like the IS equation, this is something that can be done in an exam, right? And then gives us the opportunity to ask questions about effects of real interest rates in the future on behaviors today, right? Which connects the real economy, monetary policy, and financial markets, which is the whole point of this class. Right, and so the way you solve forward, right? You just take this expression, you iterate it one period in the future, and substitute it in successively. Right. We also solved dynamic models, solve it forward. Right, so this gives us then the result here that our alpha cap depends on not only current, but also future real interest rate movements. And this real interest rate can be affected by monetary policy because of sticky prices. Right? Unless we expect inflation to move exactly one for one with the movement in the nominal interest rate, then changes in the nominal interest rate are going to cause changes in the real interest rate, and hence monetary policy will affect the alpha cap. Remember, this happened automatically in our static IS equation, if you go back to your bachelor's course, because we implicitly always assume the prices were constant. So we assume that this expected inflation term was zero. So that if monetary policy changed the nominal interest rate, automatically, one for one change the real interest rate. Right? And hence our demand for goods. All right, let's look at this reduced matrix form. So I wrote these matrices that were called AT on the slides. And so this is also this is even less complicated math than solving forward. We don't have to deal with infinite series. This is just algebra rearranging. And the reason why this is useful is we found a way to solve these dynamic models. If it's a scalar, we solve forward, and if it's a matrix form, it's solved forward. And the size, this last matrix derivation, it didn't depend on the size of the model, right? It's maybe more complicated to calculate these eigenvalues, but we wrote that down, right, with a vector x and a matrix A. It could be 2 by 2 or 20 by 20. So we have a tool, right, that we understand that we can use. So we just have to bring our models, right, into a form that can work with this tool. Okay, so the reduced form matrix was just on a 2 by 2. So we need to eliminate one of our variables. Let's eliminate the nominal interest rate, one of our endogenous variables. So we substitute the Taylor rule into our is it the Taylor rule? The IS equation, and right, we have then y tilde pi and pi t plus 1. Now we have a little bit of simultaneity here. Right? On the left-hand side, to solve to get this 1A matrix T, we need to have no leading matrix on contemporaneous variables, so the identity matrix. We need to get rid of this pi t. Fortunately, we can get rid of this pi t very easily by inserting the new Keynesian Phillips curve. Right there. And so then we have an equation where we just have y tilde, expected y tilde, and expected pi, and exogenous variables. Now for the new Keynesian Phillips curve, we have the simultaneity. There's I t and y tilde t. So let's substitute this relationship, so 39, into the Keynesian-Phillips curve to eliminate y tilde. Again, from the left-hand side, so we have an identity matrix out front. And then just simplify, and we get equation 40. So divide 40 through by this leading term here. Or y tilde t, if you notice it's the same in both of them. So we can write the system like we have equation 41, which is what we had on the lecture slides. So getting from our three equations to this form didn't involve, any law of integrated expectation or anything complicated. It was just algebra, right? Something that you learned a long time ago. Right? But it's important to be good at that, right? And to be careful about it. All right, and now we want to show that the statement was that lambda nu was positive if the Blanchard-Kahn condition is satisfied. So we got, with the method of undetermined coefficients, we got to the solutions for the output gap and inflation depending on here, monetary policy as such. Right? And we have, so kappa is positive, this is positive, it has to be because beta is between 0 and 1. This is a stable AR1 process, so that's between 0 and 1. Product is between 0 and 1. 1 minus is also between 0 and 1. So these responses will be negative if lambda nu is positive. All right, so let's look at lambda nu. When is it going to be positive? Well, it's 1 over something, so this something has to be positive. All right, can it be? Do we know it has to be positive? Well, so rho nu is between 0 and 1, so this is a positive number times our risk aversion, which is positive, and our response to the output gap, which is positive. So all the term in brackets is positive, and now we have in parentheses here 1 minus beta rho nu, that's positive, we figured that out up here, plus kappa times phi pi minus rho nu. Well, phi pi could be less than rho nu and be positive, or it can be greater than rho nu and be positive. Right? So it's not quite clear. Right? The argument here would be, well, if phi pi is greater than 1, then it's definitely greater than phi nu, and I think we've made the argument that it's positive. Now, I first made this argument, let's work directly from this Blanchard-Kahn condition. It was given to us on the slide that this must hold. All right, so if we multiply this out, can we write this inequality in a way where we can apply that this holds? Right? Why? Because we also have the difficulty, my argument here was with phi pi greater than 1. Right? But that's the Blanchard-Kahn condition only if phi y is equal to 0. If phi y is positive, right, then the central bank can respond vigorously to the output gap and not quite as vigorously to inflation. Right? So we need to be a little more careful here. Right? If we are, let's take that inequality condition. Let's multiply some of the terms out. Right, let's multiply phi y out here, and multiply kappa through here. Right, we have this first term, this has to be positive. Right, so we need this whole expression here to be at least greater than minus 1. Right, and certainly right, since this is weakly greater than 0, it could be equal to 0 in the quarter. If this whole term here is positive, then we're done. Yeah? So if the Blanchard-Kahn condition holds, this expression is positive, and they differ only by this rho nu out in front. So if this is positive, right, then subtracting a smaller negative number from the positive number is also certainly going to be positive as well. So we have this Blanchard-Kahn condition, our condition to rule out sunspots or self-fulfilling equilibria. If that holds, then this coefficient lambda nu is certainly positive, and then we get the positive interest rate shock leads to a negative movement in inflation and the output gap. Right? We have this contraction in monetary policy response. Let's think about applying this. What is it? Yeah. We can do this actually on the computer together as well. Okay. So let's think about how we can use this model and apply it to think about a question that's not directly in the model. So not what is the effect of a 1% surprise nominal interest rate, but let's apply this more broadly. And so, you know, one way to think about the financial crisis is that many people in the economy became more risk averse. Now, what does that mean for monetary policy shocks? Well, we can hopefully take a look at that. Copilot. So we have last adjusted the model to our parameters in the lecture, and then seeing what strong or less strong monetary policy would do. But now we want to think about people being more cautious, you know, after the financial crisis. That would be more risk aversion, which is our parameter sigma. You know? So let's first get our monetary policy responses, our baseline responses. Name of the mod file. And let's make our households 10 times as risk averse. inflation effect is also smaller. But the monetary policy effect in terms of the exogenous shock, we kept it the same size. This leads to essentially the same response in money growth. So blue is with the higher risk aversion. Right, now, if we think about the effect on impact, so let's again think about the direct effect and the indirect effect. Right, we get the multiplier, we look at the direct effect of government expenditures, and then all of the second round, the general equilibrium effects. So if we first take that we have the same size shock, holding everything else constant, it's the IS equation. Remember, the IS equation is output gap today, our demand for goods relative to our baseline, is equal to our expected demand tomorrow, output gap tomorrow, minus 1 over sigma, right? Sigma is our risk aversion, times the real interest rate. So if we first hold everything constant and just look at the direct effect, we have the same direct change in the nominal interest rate. It's the real interest rate. And the effect on output is now not the same as before. Instead of multiplying with 1 over 1, our original sigma, it's now 1 over 10. So the decrease in the output gap should be the direct effect about 1/10 the size as it was before. Right? Which is what we see roughly here, right? We have the indirect effects, the general equilibrium that we'll think through in a second. And so basically what's happening here? What does it mean if we're more risk averse? This means we have a stronger incentive to smooth our consumption. We're not going to react, we're not going to change our consumption, we're not going to adjust our plans very much in response to a change. I'm very risk averse. I want to keep, and that means I want to keep things the same across risky situations and also across time. I'm going to try and smooth consumption more strongly, which means a given change here, a given change in interest rates, is going to have a much smaller effect on my demand for goods. So interest rates have gone up. This would be a good time to save, and I do save a little bit more, but not by as much as before, right? Because I have my plan beforehand, and I really don't want to change it. Right? I'll change it a little, but I'm not going to make a big response, as big a response as before, because I have a stronger preference for smoothing consumption. We have another great interpretation of this parameter. our constant of relative risk aversion. And 1 over sigma is what we see in our IS equation. This is the intertemporal elasticity of substitution. It's the best way to make friends with non-economists as an economist is to talk to people about the constant of relative risk aversion and the intertemporal elasticity of substitution. Right? So if you're at a party somewhere and you want to make friends, talk about no, I'm just kidding. No, this is big words too much, and but it's actually really kind of cool here, particularly that these two numbers, are inversely related in this model. And if something is more elastic, right? This means elasticity. Do you know what elasticity means? Right, so something that you can pull and stretch it, is elastic. So like a rubber band is elastic. This is not elastic. So the elasticity of substitution is how we're able to stretch and change things across time. So if this elasticity is higher, this means we're more able to stretch things across time. Which is the same thing as being less risk averse, in the sense that we are less averse to things being different across time. Right? And you can think of right, we can think of having things might be changing across time, or you can have things be changing across maybe states of the world. Right, so think of something like we have like space-time in economics. Right, for risk averse, we want things to be constant in good times and bad times, just like we want things to be constant today and tomorrow. There's two different types of states of the world. One is a temporal, a time-based state, and the other is maybe business cycle states. And if we want relative risk aversion, we like these, we're averse to things changing, or our consumption, because it's consumption-based measure, changing across states of the world, however they may be defined. All right, so our so the response then in inflation, the output gap doesn't move a whole lot. This means that marginal costs don't go down a whole lot, which means firms aren't interested in reducing their prices as much. There's less in a decrease in marginal costs, right? Less in a decrease in their less of an increase in their markup, so less than of a price decrease that they would want to choose in order to realign their markups. Right, so if the output gap goes down, then less, and inflation also goes down by less than the New Keynesian Phillips curve. Our nominal interest rate ends up going up by more. Remember, the direct effect should have pushed the nominal interest rate up to 1, and this reduction happened because of the systematic component of monetary policy in the Taylor rule, that we would lower the nominal interest rate if we see the output gap and inflation going down. Well, they still go down, but they go down by a whole lot less, which is why our reduction from a number of 1 now only goes down to 0.75, whereas before it went down to 0.4. So this general equilibrium effect ends up being smaller. Right, now the real interest rate ends up being a little bit higher. We have two effects here. One, the nominal interest rate is higher, and we're subtracting, so the difference is a little bit less between these two. Work this out. So the nominal interest rate is 0.4 minus 0.18, so this gives us to 0.68. Here, right, it's almost all coming from the nominal interest rate because the movement in expected inflation is a lot smaller. So the real interest rate ends up being closer together, but its composition is a little bit different. Whereas before, there was a large portion of the real interest rate being driven by expected inflation. Now, most of the real interest rate movements is following one for one the nominal interest rate movements. Okay. All right, so this I chose a value of 0.3, and we were looking at an expansionary monetary policy shock, so a surprise decrease in nu. Let's just go back and see. This may be useful. Let's go 3. Otherwise, things should be the same. And we want to get a negative shock. Minus out in front of our monetary policy. Process, the shock in the process, and let's see what happens. Hopefully we get something that's similar to what I put. The output gap goes up by about 0.1. Inflation, this is in quarterly inflation. So if we multiply by 4, we get our annualized inflation. Output gap and output are the same. Natural rate hasn't moved. We have a decrease in the interest rate on a quarterly basis. So this is, I should use the figure that I just made here with you guys. I have everything annualized again. Yeah, we'll do that. And this gets us that. But so it gives us the exact answer that I have here, just things properly expressed in terms of annualized terms. And so again, what we've done, the model, so to get the negative shock, we just put a different sign up here. Right? So instead of a positive, we want to make it negative. Now that's how we could get down there to produce a figure with a negative shock. We've together we've looked at changing some of the options. We changed the length of the IRS, the variables to include in plotting. We've added in new equations. The annualized money growth rate we added in here. Changed parameter values, and having added new equations, we also added in variables here. Right? So today with this Keynesian model, we poked at everything, a little every part of it here. I would suggest, right, poke at some other things too, right? So you ask questions: what happens if this parameter changes? What happens if that parameter changes? And why is this useful? Well, we can think about our intuition, the way the IS equation should work. All right, risk aversion goes up. This means this interference elasticity substitution goes down, which means for any given change in the nominal interest rate, the impact on the output gap should be lower. Right? And we can produce the figures from Dinaire and see if that holds true, and then also what the effects are from general equilibrium of these things feeding back in. Right? The interest rate then responds as well. Okay. So we can model then more cautious risk-averse households, changing sigma. Right? And we have this consumption smoothing argument that we've seen also from this more classical or the simplified consumption savings model that we saw. Right? Okay. How about another application? So over the past decades, monetary policy communication has become more important. How could this be interpreted in the new Keynesian model, and what are the consequences? Monetary policy communication has become more important. So we're going to think about communication and monetary policy. Right, we can think maybe the variance, right? So we didn't look at the effects of variance, right? So, but you can think of realizations. There are going to be smaller monetary policy shocks. These were mistakes or mismeasurements or maybe miscommunications. Right? Or also, we could have an increase in the persistence of deviations from monetary policy rule. Right? We can think of monetary policies now able to say we're going to increase the interest rate despite what our rule says. We have this systematic component of monetary policy that tells us we respond to the output gap and inflation. We're going to do something different now. And this communication, if we have effective communication, this deviation could be sustained longer. So we could think of increasing the autocorrelation term, the exogenous process. So it's linear. If we decrease the standard deviation, it's just scaling everything down. Right? So all the effects will be smaller. Okay. I gave you a good reason for why we could get away. But I think the reduced uncertainty would probably be a decrease in the autocorrelation. And that's indeed what we would see here. These shocks would then be, I don't know. So here we have the effects as the autocorrelation increases, right? We know from the way we solve the model that it's going to, all the variables are going to inherit the autocorrelation from the shock process. So an increase in the persistence being better monetary policy communication. So I like the explanation that I gave, that we can get away, we can sustain larger deviations from this rule if we communicate them properly. But you could also actually, so this is a good example of an exam question where someone might give the exact opposite answer that I'm expecting. I don't know, and if it's a well-argued answer and it's correct, then it can be 2, because there's no one single way to interpret this question, because we don't have a parameter, monetary policy, that we can change, right? Where it's clear what exactly this means. This is you now, right? Being masters of the universe, students that, you have a great command of economics, so you can think outside of the box, right? And of course, the problem with thinking outside the box when I'm in an exam setting is that, by definition, you could go to the left, to the right, to up, down. Outside the box can go many different ways. Yeah? And I would, I would beg you to then, trust yourselves, right? And try to think out of the box, your own way. Have some faith that I'm going to read your answers, and if you make a good argument that I wasn't expecting, right? But it's a well-founded economic argument, that's the right answer. Because as you go forward as economists, your job isn't going to be giving the one correct answer, because it's not going to exist. There's not going to be, the answer was 27.4, whatever the question might be, right? It's going to be, this on the one hand, on the other hand, from a suite of models, we have some general idea about what's going on. All right, so the other way that you could think of this, I think, is that if monetary policy does a good job at communication, then any mistakes that it might make will be quickly lived. So if I make a mistake as monetary policy, if there's a shock, right, where my policy rate was different than what we would have together with, or would assume from the systemic part of monetary policy, that this mistake would quickly disappear. We would quickly communicate, look, yep, it was a mistake for whatever reason. Interest rate, output gap was lower than we expected, so but it was a mismeasurement, and we solved the problem. I would expect perhaps maybe that there will lower autocorrelation, so that monetary policy shocks would, by their very nature, be less likely to happen. And if they were to happen, they would be shorter lived. You could also make the exact same argument, which is what I have in the slides that I'll upload in a little bit. And that's what I first told you, is that, well, with communication, we can sustain longer deviations from our policy rule. Right? And this would, so one would tell us that monetary policy becomes much more effective. Right? A shock now has very strong, long-lasting effects. The other one tells us that shocks themselves should be less likely to occur, smaller deviations, and be very short-lived. Because we're communicating more transparent, we're less likely to be making mistakes. Right, so we can see this going both ways. All right. So I have then some outlines of some of these self-study questions. Right, we can think about now, you can play around with Dinier, if you wanted to increase economic output. How do we get output to increase more quickly? We think of stuff like technology shocks or monetary policy shocks, combination of the two, changing persistence, or how would you approach this question? And now we can think of a little beyond this model. What if technology shocks themselves are our policy? How does this change the way we think about monetary policy and productivity shocks from what we did earlier today? And this is like really important in a country like Vietnam, right? Rapid development here. One way we can think about economic policy from the government here in this model would be, generating or letting these technology shocks transmit to the economy. So we have lots of these positive technology shocks, productivity increases that are happening all the time. We saw that the effect of these technology shocks on actual output can be very different depending on what monetary policy does. Yeah? Right, so you can think about maybe there's a reason for monetary policy to work closely, right, with economic policy from the government here. Or maybe they should be complementing each other. Like, what happens if we have a technology shock that's less than all the others? So if we have we have strong growth, but in one quarter, 1 year, that growth is a little slower, right? Monetary policy could maybe contribute to that. Maybe it's also this growth, the standard growth theory. We think about technology improving, and it's always labor augmenting. Right, so it goes hand in hand with labor. And here in this model, it's out front. It's called total factor productivity. Right, so maybe this level of measured technology is a little bit different in this model than in standard growth theory. We can think about think about some of your insights from growth theory that you thought about it being like a solo type model, and how this would connect to this model. Right? Where we're thinking more about variations around the steady state or variations around the path. So maybe monetary policy is a good complement to deviations of growth from the government's plan, right? But along the government's plan, perhaps monetary policy should be neutral. And monetary policy maybe has a stabilizing role. It shouldn't be, bringing growth along. Right? So there's a number of things we can start to. I just close my. Right? You can think about these, and I just put some graphs here, and then some of my thoughts on the differences. Yeah? And look at, but I would, these are great sort of questions, not just for the exam, but in general as economists, is like, let's confront you with things that are sort of a little bit outside of the model, again, thinking outside the box, right? And get those wheels turning, because you're now, as master students, you're really making this transition here from being a student to being experts. Yeah? Right? You've learned a lot of different theories, a lot of different methods. Right? For your bachelor studies, and now you're in your second year here. Right? When you're done, you're going to be full-fledged economists, and people aren't going to give you questions like exam questions, right? You're going to be at the Ministry of Finance, and they're going to ask you a question that's like, well, this kind of sounds a little bit like that model, and this model, sort of put together. How would I put the little pieces that I've learned together to give one coherent answer? And that's my ultimate goal for you guys when you're finished with this course of studies as economists. Yeah? To take the different tools that you've collected here and to apply them to problems that aren't directly from, the textbook for the one. But this is a self-study way to do that. We have a little bit of time left. I just want to give you a flavor of what we're going to start doing tomorrow. We're going to be doing the same thing we did today, the same thing we did yesterday. We're going to do the new Keynesian model, but now we're going to add one thing. We're going to be adding an open economy component here. So it's really sort of the same way of thinking that we went from the first day to the second day, from ISLM to Mundell-Fleming. And things get a little bit more complicated, kind of in ways that we didn't expect, or wouldn't have expected right away. So, sure, we have exports, net exports, exports and imports, right? We thought about things like Marshall Lerner conditions before. That's less of what's important for us now. Now what's going to be more important is there's no longer one single inflation rate. There's not the inflation. We have a couple of different measures of inflation. Do we have the inflation of the aggregate changes in the price of the goods that we produce, or the aggregate changes in the prices of the goods that we consume? They're different. We can have constant producer prices in Vietnam, but have high inflation of consumer prices if, say, the prices for the iPhone go up, or other products that are imported. These are things that Vietnamese people buy. This is in their consumption basket, so in the price level that's relevant for the Vietnamese person, the prices of imports are important, right? And these prices might move differently than prices of production in the economy. Okay, who cares? Well, we care, that the Vietnamese consumer cares, and the Vietnamese producer cares, but also monetary policy. We are more likely to be able to control or to affect movements of producer prices than we are consumer prices, because it's hard for us in Vietnam to affect, to influence the price of oil, for example, or the price of the iPhone. If those prices go up, that's beyond our control. Right, so this might, the thing that's most relevant for our consumers is now something that's more difficult for us to control. And on top of that, our monetary policy rules also affect, are affecting the producer prices, affects maybe the exchange rate, which is going to affect external demand for our goods, but then this exchange rate is also going to affect our import demand, which is going to compound with the prices changing from abroad. Right, so the whole idea is going to be to thinking about how this exchange rate and openness in trading alters these IS and Phillips curve relationships and the transmission of monetary policy. Oh no, I did this. I'm going to recompile these because I hate it when I do this. Do you see that effect? Wow, are you impressed now? Yeah? Okay, so we're going to look, there are many different ways that you can, and there are many different ways in the literature to model small open economies. Right? We're going to have or open economies, we're going to have a small open economy. And our economy is going to be very small. It's not going to be the 15th largest country in the world by population, which is Vietnam, right? Our country is going to be infinitesimally small, right? We're going to be smaller than Macau, smaller than Djibouti, smaller than the Vatican City or San Marino, right? We're going to be infinitesimally small. This is going to motivate the way we interact with the rest of the world, because in our model here, changes in our domestic prices aren't going to affect demand abroad, total demand abroad. Right? They're going to buy less of our goods perhaps, but this doesn't change the situation in the rest of the world. That's not the case. Even for Vietnam might not be the largest country in the world, but Vietnam is a non-negligible. It's certainly a lot larger than infinitesimally small. Right? If Vietnam raises its prices, right? If we, think of adding please don't, but add an export tariff, right? The government could start adding on 15% of the price of every good that leaves the ports of Ho Chi Minh City and Hanoi, right? You could do that, make Vietnamese goods more expensive for the rest of the world. In our model, that would just mean people in the rest of the world would buy less. They wouldn't be any poorer. Their income wouldn't go down as a result, right? They would just simply buy few of our goods. A lot of the world's income production, it would make people in the world poorer if Vietnamese goods became more expensive, because Vietnam is a big enough country. We're going to shut down that possibility in the model here. We're going to think of a country being so small that whatever it does, it has no effect on the rest of the world. We're also going to consider a world where we have complete international financial markets. And what this means is that Vietnamese invest not only in Vietnam, not only buy Vietnamese bonds, they also buy German bonds and American bonds. And Americans and Germans buy American, German, and Vietnamese bonds. And if we really had perfect risk sharing, so we had perfect financial markets and people really thought like to be global citizens, we would all be trading in bonds and all sorts of commodities to protect ourselves from risk from any one single country. I think of, imagine you thought about risk aversion and insurance on financial instruments, right? So the correlation of payouts with our hunger, our marginal utility for consumption. So when this, at the same time, when you are very likely to be very hungry, let's say to have lost your job, right, is the same time when a Vietnamese security or bond is likely to have a low payout. When Vietnam goes into a recession, at that time, it's the same time when you are likely to be very hungry, to have lost your job, and at the same time, if you own a lot of Vietnamese securities, they're likely to give you a lower payout. Right? Our models that we thought about with arbitrage or people trying to minimize risk, with our risk aversion and pricing of assets, should tell us that we should try to diversify this risk away. So particularly if my income is from Vietnam, I should try and invest in securities that have the exact opposite movements, right? So that which countries' bonds are going to pay out a lot when Vietnam's not doing so good, right? So which countries are the exact opposite sort of spectrum of the trading world, right? We don't see this in reality, right? So we're going to make an assumption in this model that makes a lot of economic sense. We should be global people, right? And we're making our investment decisions. We shouldn't invest disproportionately in the same country where we get our income. This is exposing ourselves to a lot of risk, right? But if you look at probably Vietnamese who own bonds and securities, or who invest in real estate markets and the like, they probably disproportionately invest in Vietnam. Right? The same is true of every country. But this, from an economic standpoint, well, this is kind of dangerous. You're putting all of your eggs into one basket. It might be the beautiful, fantastic Vietnamese basket, but it's still all your eggs in one basket, which is not very diversified. Where we saw big problems with this was in Greece, in the European debt crisis, because the Greek government was running into problems financing its debt, so it had to cut government spending and this and the like. So the Greek economy went into a recession, and who were the people who were holding the Greek bonds or Greek securities that also started to lose value, to go bankrupt, or to default on their payments? That was disproportionately Greek people. So the Greek people got hit twice. Once with the recession, and twice with the loss of the value of their securities. That's not going to happen in our model. We're going to have perfect risk sharing, consumption smoothing across countries. We are savvy enough, the people in our economy in this model are savvy enough that they're going to trade. The Greeks are going to trade with the Vietnamese, with the Germans, with the Americans, so that all of this country-specific risk that we have is going to be spread around the world equally. So we're going to have the same risk, no matter what country we're in. This is perfect risk sharing. And we'll see how this is going to give us some relationship between interest rates, exchange rates, and the like. And to close that, we're going to also then assume that we have, in the long run, the law of one price. So at the very least, in the very long run, the goods that we produce, right, a white washcloth from Vietnam in the long run is going to have the same real price as a white washcloth from Germany. And so if we relate the two nominal prices, that's going to give us, at least in the long run, the nominal exchange rate. Right, so these are assumptions, right? To be sure, these are perhaps some extreme assumptions, but they're going to give us a model that's tractable that we can work with. And then we can then also extend to include other things. You can have weight rigidities, or we can then do all sorts of other things. All right. So when we start back tomorrow, we're going to go through the model. We're going to have households and firms. We're then going to look at risk sharing internationally, how this gives us the uncovered interest rate parity condition, how we get equilibrium, interest rate rule, and we're going to look at different ways to specify monetary policy, which inflation rate should monetary policy respond to. All right, we have the Taylor rule. I is some phi pi times pi. But which pi? All right, now we're going to have different pi's to think about. But we'll do that together tomorrow. I think it's a good place to stop. So thank you all, and see you tomorrow.
Thank you.